Welcome to week 5 of distance learning. Today we are going to start our next unit on the solar system. In this unit we will be completing 2 tasks this week. The first one will be creating a scale model of our solar system, and the next will be researching facts about the solar system. So let's get started with the assignment for today, called Solar System Scale Models. You'll open it up. For this, you'll watch the video that I'm recording right now. Complete 3 of the 5 assigned of the tasks that I give you. You will need to do tasks 1 and 2. Everybody will. And then you can choose from the remaining 3 tasks to do 1 more, giving you a total of 3. There will be a link for the video along with a ruler if you need it, and then the assignment itself. Opening up the assignment, called Scale Models of the Solar System, using this calculator called Exploratorium Calculator. I'm asking you to complete task 1 and 2, and then choose a third task from the remaining list. In this case, the third task, the task I'm choosing, is task 3. So let's get started. Task 1 says, how far are the planets from the sun? So in a scale model, we are creating a smaller version of the solar system because the solar system is immense. And so by making that smaller model, we can look at those distances and have a kind of a more manageable model. So for this, we're going to open up the calculator, and then we are going to first record the actual distances that the planets are from the sun. And you'll see here I've already done Mercury, making it 57,950,000 kilometers from the sun. And then what we're going to do is we'll open up the calculator to look at that. As you can see here, we'll scroll down. Here's our calculator. So here's that number, 57,950,000 kilometers. The distance that Mercury is from the sun is 0 distances from itself, so the scale would be 0. Now, the next part we need to do is find our scale distances, and the number I want to use for our scale is we're going to base our scale on the size of the sun being 8 millimeters wide, which is a little less than a centimeter. It's pretty small, but the distances are pretty big. So in our calculator, we're going to go to that green box and we're going to put 8 in. Okay, so that's saying if the sun was 8 millimeters wide, how far would it be to the other planets? Hit our calculator, fills our numbers in. We're actually just going to work with this last column here on scale distances in meters. So for our scale, if the distance to Mercury is 57,950,000 kilometers, and a scale, it's only going to be 0.3 meters. And so you see there's a set of numbers, each of these representing a distance from the sun for each planet. So I'm going to record 0.3. I'm just going to round it to that tenth, that first number. So the scale distance would be 0.3 millimeters, or 0.3 meters is how far it would be to Mercury. You're going to then repeat that for these other planets. Now, once you have completed the table using those set of numbers here and here, then there's just a few questions. So you're going to look at these numbers and say which 2 planets are closest to each other. So which one has a number that is closest to the same distance from the sun? And remember, it has to be 2 planets that are next to each other. Mercury is going to be much farther, is going to be much farther away than Jupiter. It has to be a planet that's right next to each other. So you can either use these numbers or these numbers. Pick 2, look at this, 2 that are closest to each other. And then which planet is closest to halfway? So if the distance to Neptune, you're going to say which number is about halfway between the sun and Neptune. So which planet is halfway? That's task 1. Task 2. Task 2 is we're going to look at the size of the planets and compare them. Again, we're going to use that calculator and we're going to do the same thing, only this time we're going to record the actual diameters and then the scale size and then something about the same size as our scale size. So let's go back to our calculator and we're going to clear it out, and this time it asks us to use 250. So that's saying if the sun were 250 millimeters, which is about 25 centimeters, which is about the size of a size 5 soccer ball. So let's calculate. So we're going to use these numbers here. These are the diameters, or the width of the planets. And then this is our scale. So for Mercury, it is 4,866 kilometers across. And in scale, that would be 0.8 millimeters. So in our table, we're going to write 4,866 kilometers, 0.8 millimeters. And actually then, let's look at a ruler. So 0.8 is less than a millimeter. So here's our calculator. I'm going to rotate it, and we'll look right here. So each one of these numbers here is a centimeter. Millimeters are 10 of those. So each of these little lines is a millimeter. So we're saying that the diameter of Mercury in our model would be less than one of these little lines, or about the size of a grain of salt. So you're going to do the same thing for all your other planets. Write in the actual diameters and then the scale diameters there. And then you're going to answer two questions. Which two planets are about the same size? Either use your scale numbers or your actual diameters, and then put them in order from smallest to largest. So these are the two tasks you have to do. The next one, your age on other planets. So you're going to go and click on this link, and we're going to record your age that you would be on each planet and when your next birthday is. So open it up, and let's say my birthday is the first month of the year, on the first day of the year, and let's say I was born in 2000, and I'll hit calculate. So then if we look down here, and we look at the years numbers, this would be how many years old you are. So if you're on Earth, if you were born on January 1st, 2000, you would be 20 years old and 3 months, or 4 months. And your next birthday would be on December 31st, 2020. Okay? And you'll see that there are different numbers for each of the planets. We're going to record those in our table for each planet, as you can see here. Obviously on Earth, it would be whatever whatever your birth date is and your age now. And then one question, why is it different on other planets? Your clue for that is to read this little piece of information down here, which will help you to understand why they would be different. That's task number 3. Number 4, we're going to do this with your weight. So I'm going to say I'm 200 pounds. I'm going to open up that calculator. I'm going to type 200 in, and I'm going to calculate. And this is going to tell me how much I would weigh on every planet. Now you see Earth isn't here because 200 pounds is how much you weigh. This then shows you how much you would weigh on the other planets. And we'll write that in here. And then why does your weight change? Again, like the previous one, we can look at this little reading here and read through that, and that will explain to you why you might weigh differently on different planets. Now, our last task is task 5. Now, in task 5, we're going to ask you to do a little measurement at home. And what you're going to do is you're going to stand and you're going to do what's called a standing broad jump. And here's a video on how to do a standing broad jump. You're going to do it 5 times. So you're going to find your average. So down here, let's say I did 5 jumps. And my jumps came out to an average of, came to a total, if I add all my jumps up to 30, divide 30 by 5, it gives me an average of 6 feet per jump. So I would write that here. And then down below here, I'm going to do the math. So we know that the force of gravity on Mercury is 0.4 of what it is on Earth, which is 1. So it's a less. And I know my distance I would jump is 6 feet. So we're going to take the number we jump, divide it by that 0.4, giving us 15 feet. So if you were on Mercury and you could jump 6 feet on Earth, you could jump 15 feet on Mercury. That's what I'm asking you to do there. So these are your tasks. Task 1 is figure out the distance of each planet, answer some questions. Task 2, compare the sizes of the planets, find objects about those sizes. Task 3, find your age and what your birth date and age would be on each planet. 4, comparing your weight. 5, how far would you jump? if you're on each of the planets. Complete 3 of the 5 and you'll have completed this assignment. Now, if you have any questions, again, email me or put comments in the assignment, or come to office hours on Tuesdays and Thursdays. I look forward to hearing and seeing what numbers you come up with, and I hope you have a great week. Bye.